how are you? We're going to do a video today that has to do with absolute value. My name is Katya Severson. I'm the inventor of the Severson method, a scientifically proven way to learn anything fast, especially the absolute value. And I kind of know what many of you are thinking, like, come on, Katya, why would you want to talk to us about absolute value? Absolute value is so easy. It just has to be positive all the time. Why don't you do another history passage walkthrough? Why absolute value? There is a reason, chickens. I find that there are a lot of different facets of absolute value that the SAT tries to test. And when they do that, they often catch you off guard. And my colleagues who I respect and love, like Nelson Fu, for example, he doesn't, in my opinion, doesn't give enough attention to the absolute value. So with my clients, I find it essential to go over specific types of questions. And to keep these serious, short, and sweet, we're just going to cover every facet of absolute value in a tiny little video. And in this video, we're going to be talking about absolute value equations and absolute value inequalities, the basics, how to solve them, how to approach them. If you're shooting for 800 on the math section, make sure you watch all of the playlist all the way through, including the video on marginal analysis. So you could estimate your margins based on absolute value. And this one I find really, really tricky. So let's go. I'm going to minimize myself and I'm going to give you an example. And then I'm going to be showing you real examples from the SAT. What I want you to do, guys, I want you to pause the video, attempt the question by yourself, and then only go back to me. So that I don't have to say pause the video. Just every time I show a new example, just train yourselves to pause the video, because that will give you a really good opportunity to actually see whether you're understanding or you're thinking that you're understanding. When I was in college, I found myself always just watching Sal Khan, who I love. Thank you so much for teaching me all of the things about finance. I would just watch him do a problem, and yeah, that makes sense. But then I would turn off the computer, go to the test, and have no idea how he did it. So make sure you actually give yourself ample opportunity to fail and make mistakes, because it's a safe place. We love everyone who tries, even if they make mistakes. First slide is just two basic absolute value thingies. On the left, we have absolute value equation. The reason we call it an equation because there's an equal sign, and on the right, there's an absolute value inequality. The SAT would usually not give you something as easy as this. They would usually give you like coefficients. Maybe there's going to be a 3 in the front, or maybe there's going to be like 4 plus or 4 minus this. So the first step, whether you're solving an absolute value equation or absolute value inequality, always has to be to isolate. You have to make sure that the absolute value is by itself on one side of the equation. So on the left, we would probably have to divide by 3. So we would divide both sides by 3, get rid of a 3 in the front. And on the right, we'll have to subtract 4 on both sides. So remember, first step to isolate. But we're going to do that. We're not going to do this here because we're trying to keep it simple. And to solve an absolute value equation, I suggest that you just drop the walls and you rewrite 2 equations instead of 1. You just write x minus 5 is equal to 6. And the second equation is going to be x minus 5 is equal to negative 6. You see, we're keeping the insides of the absolute value intact. We're just changing the side on the right. We're making it 6 and negative 6. Then when you solve both of these equations, you're adding 5 on both sides. Here, x is going to equal to 11. And then here, x is going to equal to negative 1. The SAT always loves to ask questions about the sum of the 2 solutions or the product of the 2 solutions. So the sum would be 10 and the product would be negative 11. Now let's go over to the right side and solve an absolute value inequality. This one is a little bit different, and maybe your high school teacher have proposed a more sophisticated, probably more correct way to do this, but on the SAT, we're all about shortcuts and eliminating probability for making a mistake. So we want to eliminate errors, and here's what I suggest. The exact same direction in which your inequality sign is, you just write 2, and that's how you're going to drop the walls. Next thing you're going to do is just going to rewrite exactly what you have in your absolute value in between those 2 signs. And then on this side, you're just going to say -4, and on this side, you're going to say 4. Then you're going to add 7 on both sides to isolate x, and then x is going to be trapped between 11, 4 plus 7, and then 3, -4 plus 7. That's your x, and that is your solution. If you wanted to know how to graph this, I'm happy to show you, but this is going to be a little separate subsection. We're going to be very segmented today. Next, a couple of examples from the real favorite amazing SAT. All right, here they say that the value of one solution to the equation above is 1. What is the value of the other solution? Okay, you already know how to do this. What you're going to do is you're going to rewrite this equation 2 times. 5 minus x is equal to 4. And then you're going to write it as 5 minus x is equal to -4. Then we're going to say -x is equal to -1 because we're subtracting 5 on both sides. And then -x is equal to -9. Then because we need to multiply by -1 to make it x is equal to 1, which we already have, and the other answer is x is equal to 9. The last thing that you always have to do with absolute value equations is you need to plug it back into the equation, see if that works. Because with absolute value and with radicals, you sometimes have a lot of, they're called extraneous solutions, extraneous roots. So just to be sure, let's plug 9 back into the equation. 5 minus 9 is going to give us -4. Absolute value of -4 is 4. It works, so the answer should be 9. Next question. Again, I'm not reminding you to pause, but pause. See if you can solve it by yourselves. Here, we're going to rewrite the equation. Again, we're going to rewrite 2 equations. I need to minimize myself again. Tiny Katya. X minus 7 is either equal to 18 or x minus 7 is equal to -18. Now, add 7 on both sides. We're going to have x is equal to, looks like it's 25, and then x is equal to -11. So the answers are -11 and 25. It's C. There you go. Next question, this is 31. This is feel free to use a calculator. Here, remember how I was telling you about a product? Here, they want you to solve for x and y using the process that you very well know, and then they're interested in one possible value. So this is going to be a multitude of answers. So 2x plus 3 is equal to 5, and then 2x plus 3 is equal to -5. 2x is equal to 8, x is equal to 4. So one possible value of x is 4. Another possible value of x is going to be 2x is equal to -8. And then, how did I do that? Why did I, be better than your tutor, okay, guys? 2x plus 3 is equal to 5, and then 2x is equal to 2, not 8, because when we add on one side, we subtract on the other. So this is 2, then divided by 2, the answer is 1. So one possible value of x is 1. Then here, 2x is equal to -8, and then x is equal to -4. That's another answer. Now for y, let's do this. Let's change color. Y is going to be blue. Disgusting green is a good alternative. So we have 3y minus 3 is equal to 6, or 3y minus 3 is equal to negative 6. Negative 6. So we have 3y is equal to 9 and y is equal to 3, which one possible combination would be 3 times 1. Absolute value would be 3. Then you have 3y is equal to negative 3, and then y is equal to negative 1. So you could do negative 1 times 1, for example, so the answer could be 1. You could do negative 1 times negative 4, so the answer would be 4. So there are multiple answers, and I'm sorry if I didn't call out your answer. It's just one of the possibilities. Next question, question 17, very similar setup. Please pause and give yourselves a chance to answer it by yourselves. 2x plus 1 is either equal to 5 or 2x plus 1 is equal to negative 5. Sorry, I think that this side of the screen doesn't like to be written on anymore. So 2x is equal to 4. X is equal to 2. 2x is equal to negative 6. X is equal to negative 3. So one solution is 2, another solution is negative 3. So 2 minus 3 is going to be 5. Absolute value of 5 is this. You can also do negative 3 minus 2, which was going to be negative 5. Absolute value of negative 5 is going to be 5. So 5 is the answer here. And then last but not least, let's go over this one. Here they're giving you different values of x, and all you need to do is you need to verify if this is going to work or not. If we plug in negative 12, it gives us negative 2, because negative 12 times 1/2 is negative 6. Negative 6 plus 4 is going to give us negative 2, and absolute value of negative 2 is 2. So negative 12 works. So does negative 4. But positive 4 doesn't work, because then you're going to get 6. Absolute value of 6 is not 2. So the right answer here is C. I hope you enjoyed this video, guys. There's going to be a lot more. We're going to do a whole little playlist on absolute value tricks only. I'll see you in the next video. Bye.